So here's the really good news, ladies and gentlemen. Everything that we did for chi-square test for homogeneity is exactly the same process for the chi-square test for independence. The only difference is like which one you call it based on whether you have one population with two variables or two populations and one variable. So chi-square test for independence is when you have one population, but you're going to compare two variables, and the whole point of this is to see if an association exists. So the null hypothesis in a chi-square test of independence is that there is no association between the two categorical variables in the population of interest. What would be the alternative? There is an association in the two categorical variables in the population of interest. Every literal other part, including the calculator part with the matrix and all that, is exactly the same for this as it is for the homogeneity. So, how do you know whether you're doing a chi-square test for independence versus a chi-square test for homogeneity? Two variables, one population, that's chi-square test for independence. One variable, but two or more populations or treatments, that is the homogeneity. The only thing that's going to be different is the way you write your null and alternative hypothesis, and then when you state which chi-squared test you're using under the do, that's the only parts of the whole thing that are different. Okay? You feel like who what? Well, but there is. All right. Now let's talk about follow-up analysis. So, when we complete a chi-squared test for a two-way table and we get statistically significant results, what does it mean to get statistically significant results? What does that mean to get statistically significant results?
The p-value is low.
That is when your p-value is low and you rejected the HO. Your p-value was less than alpha and therefore you rejected the null hypothesis. That means you got statistically significant results to prove your alternative hypothesis. All right. So, again, if we get a statistically significant result, we've rejected the null hypothesis, we've said the alternative is true, and we now believe that there is in fact an association, or there is in fact a difference in the two different populations, we may want to know, what is that difference? Like, where is the difference? Like, what is the association? How are they associated? So, we can do a follow-up analysis. Doesn't this chart look fun? So this is the same example from Monday with the food and the music playing. Okay, so this is a homogeneity test. But this is a printout. What in the heck is going on here? So what I want you guys to see is the very first line of each of these blocks. Those are the observed counts. The first line of each block is the observed count. Then, if you look at the second line of each block, what does that look like? That is the expected count from each of those. Do you guys remember how to get expected counts by hand?
Observed minus expected over expected. Over
Squared
Row total times the column total divided by the table total. Okay, cool. So that's how you get expected counts for each individual cell, if you needed them. Okay. All right, cool. And then there's a third line for each of these blocks. Looky there. Ryan just coming in hot today, ready to learn, teaching the class. These are the chi-squared contributions for each of these cells. So these are the chi-squared contributions. How do you get the chi-squared contribution?
In the calculator.
Yeah, but how do you get it by hand if you needed it?
Solve the individual thing.
Observed minus expected squared divided by expected. So each of these is the observed minus the expected squared divided by the expected, and I get that number. Observed minus expected squared divided by expected, I get that number. Okay, cool. So why these ones that are blocked here, that are squared, why are they so big? Why are these chi-squared contributions so large?
Large difference. Different than theirs.
They have the biggest differences relatively speaking, okay? Why is this one 0?
No different.
Those are basically the same, right? 35 and 34.88, that's basically the same, okay? So, very good. All right, down here along the bottom, we have the chi-squared test statistic. How could I get that chi-squared test statistic from this table, this chart that I have here? I could add all of the contributions. So this is the sum of the chi-squared contributions. Very good. Awesome, awesome. You guys are doing great. DF equals 4. What does DF stand for? Degrees of freedom. How do I get degrees of freedom for a two-way table? Row minus 1 times column minus 1. Very good. And then there's something here that says p-value. What is that?
Something extreme, as extreme or more.
This is the probability of getting a sample as extreme or more extreme than this, assuming that the null hypothesis is true, which is that there was no difference in the entree ordered based on the music that was playing. Is there any way to get the p-value if I know the chi-squared test statistic? Chi-squared CDF. You can get this by using chi-squared CDF. So it's almost like there's 2 ways to do everything in this unit. Whee! All right, so back to the follow-up analysis. What does this tell us? So let's think about this for a second. This was the French music playing, and then I don't know. What was the food? What order did the food go in down the side? Do you remember?
French, Italian, other.
French, Italian. Okay, so this was French entree. This was Italian entree. And this was some other type of entree. Okay, cool. So, what does this tell us about this situation? Yeah, like the fact that these chi-squared contribution, these 2 particular ones are so big. I mean, look, they almost take up 14 of the 18 of the chi-squared statistic. So, what does that kind of tell us about, the food and the music and how we could manipulate people? What does this kind of tell us? So if you notice, both of these are in the Italian entree row, right? So when I played French music, I had very few people actually order Italian food than was expected. So only 1 person did when we expected almost 10 to do it. So when I was playing French music, it really influenced people away from Italian food. But when we played Italian music, what happened? I had 19 people actually order Italian food, and I only expected 10.72 or 11, right? So what does that kind of tell you overall about what is influenced? What specific entree is most influenced? Italian food is most influenced by changing the music. Okay? That's basically, we can look at this and go, okay, I mean, basically when we don't have any music playing, we're getting pretty close to what we expect for the distribution of entrees. French food, I mean, yeah, it kind of changes here, but Italian food, or French entrees aren't really that influenced by changing the music from French to Italian. But the Italian food was really influenced when I changed from French to Italian music. And then other entrees, you know, it didn't really matter if I was playing French or Italian, it didn't change their mood. So the kind of overall analysis after looking at these little details is it appears that Italian entrees are most influenced when I change Italian and French music being played. That's the whole idea of a follow-up analysis. All right, so here's our specific conclusion. Italian entrees can be influenced by changing Italian or French music being played. So what? Who cares? Who would care about this information?
The restaurant owner.
The restaurant owner. How would this help them in any way?
They want somewhat Italian food.
Very good. They, you know, usually in really nice restaurants where they would be playing Italian music and Italian food and all, not Olive Garden, right? They home make their pasta. Homemade pasta does not sit on the shelf forever. So maybe they've got a bunch of homemade pasta that they need to get rid of before it's going in the trash. So what should they play that day? Some Italian music, right? Maybe they've got some French entree that they're trying to really push and sell. Play some French music and you'll sway people away from those Italian entrees and possibly they'll get more French food. So this is why this could be helpful. Make sense? Fantastic. Wasn't that fun? Sure, Miss Lakey, whatever you say. All right, last example of the year. All right. Choosing the right chi-square test. Are men and women equally likely to suffer lingering fear from watching scary movies as children? Researchers asked a random sample of 117 college students to write narrative accounts of their exposure to scary movies before the age of 13. How many of you watched scary movies before you were 13? What movies were y'all watching? It?
I've never watched it in my life.
Y'all, you've never watched It? Any of you guys watch like The Purge?
No, I watched
I
it.
love the bird.
Yeah. Okay. What's another really big scary movie? Oh, Exorcist. That one is just funny.
I love that one.
I mean, I'm just
Okay,
saying.
same with the Scream movies. Those are
The
funny.
Scream movies are funny
They're
too.
like not funny, but they're funny.
They're kind of funny, especially the knockoff Scream movies.
Yeah.
Those are really funny. Anyways, okay, back to this. More than 1/4 of the students said that some of the fright symptoms are still present when they are awake. The following table breaks down these results by gender. So we've got gender and we've got fright symptoms. And then we've got the Minitab output that gives us all of the data right there. We don't even have to plug this in our calculator, ladies and gentlemen. We have our observed counts. What's the next line? Expected. What's the next line? Chi-square contribution. If I add up those contributions, I should get the chi-square test statistic. Why are the degrees of freedom 1?
It's too much.
2 minus 1 times 2 minus 1 is 1 times 1, which is still 1. P-value is right there. All right, cool. It even tells us we can assume the conditions are met. We don't even have to check the conditions. But just for funsies, do we have a random sample? Yeah, we've got a random sample. It said it. It said so. Somewhere in there, random sample. All right. Do you guys think there's more than 380 and 790 males and females?
Yeah.
Okay, cool. And then are all of our expected counts greater than or equal to 5?
Yeah.
Yes. Okay, so all of our conditions are in fact met. All right, what's our question? Our question says, should a chi-square test for independence or a chi-square test for homogeneity be used, and why?
Oh, it's a situation.
What if there's two populations? No.
Okay. How many samples or populations were, or how many samples were taken? There's only one sample taken. It was a random sample of 117. But when I took that random sample, what did I notate? Two variables, gender and fright symptoms. So this is one sample, two variables, gender and fright. And so this would be, which one? Chi-squared for independence. Cool. What are the appropriate hypotheses for this test? What is the null hypothesis? There is no association between gender and fright symptom. What's the alternative? There is an association between gender and fright symptoms. What do you guys think a fright symptom is? Anxiety, being afraid of the dark. When you're at home alone, you're listening and hearing all the sounds and going, what's that? What's that? What's that? What's that? What's that? I still do that. Like, what's that? What's that? What's that? Okay. That's schizophrenia. Thank you, Ryan. Probably. All right. Any questions about the hypotheses here? Fantastic. Continuing on. Part C. Part C. Oh my gosh, you guys, it's the last. But we're going to have to turn back one. Which cell contributes the most to the chi-squared test statistic? So let's go look at that real quick. Which of these cells? Which of the
male fears.
Which of these cells contributes the most?
The
The male, and then is this a yes or no for fright symptoms? Yes. Okay. Now look at the detail though. Okay. Look at the detail. Is there more or less males that exhibited fright symptoms than expected, or which way? There are less males that exhibited fright symptoms than we would have expected. Okay. Cool. What's the next one? What's the next highest one? Females. Are more or less females experiencing fright symptoms than we expected? Does this kind of fall into the stereotypical gender roles? I know. Doesn't that stink? All right. So what does this kind of tell us here? So back to this. So it is the males with fright show less males than expected have symptoms, while females show symptoms more than expected. So how does that differ from our null hypothesis? So the null hypothesis is that there is no association. But what does this kind of make us think? That if depending on your gender will depend on if you have fright symptoms or not. Okay? So obviously this seems to indicate an association. Kind of seems like we got something going on here. But is it sampling variability, or is there really an association? Let's look at the p-value. What is the p-value, by the way? 0.045. Okay, first we get to interpret that p-value. Assuming there is no association in gender and fright symptoms, there is a 0.045 chance of getting a sample as extreme or more extreme than we got just by chance. That's a lot, isn't it? Basically, there's a 4.5% chance that was just sampling variability and not an actual difference in gender and fright. So, okay? Everybody good on that? Yeah. Oh my gosh, you guys, 2 more parts. I'm getting really sad. What conclusion would we make at an alpha equals 0.01 significance level? P-value equals 0.045. That is greater than alpha of 0.01. What are we going to do? We're going to fail to reject that null hypothesis. There is or is not? There is not convincing evidence that an association exists. Obviously, between these 2 variables, gender and fright symptoms. Yes, you should write all that in context of the problem when you're doing the actual, blah, 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 blah. Okay. And finally, what type of error might we have made? Type 2, since we failed to reject the null hypothesis. And what would that mean in context of this problem? Did we say there was an association? No. We said there's no association, but there really is. That would be, we said no association, but there really is. What's the consequence of that? I mean, I don't know. Maybe we have less help for men than needed. I don't know. Or women. I don't know. Whatever. Ladies and gentlemen. You did it.